panel discussion number 2, which is covering operational challenges for urban air mobility, encompassing airspace integration, traffic management, cybersecurity, and data privacy perspectives. So with our next panel, just give me one second. The high volume flight operations in low altitude airspace that is expected with urban air mobility places new challenges for the scalability of the National Airspace model and current air traffic control system. In addition, the highly connected and data-rich nature of urban air mobility vehicles presents significant cyber risks and questions of passenger and consumer data privacy, which must be proactively addressed. This panel will explore emerging models for the design of low-altitude airspace, developments in unmanned traffic management solutions, and approaches for mitigating cyber vulnerabilities and data privacy issues with UAM. It is my pleasure to introduce our moderator for our second panel, Dr. Jim Gregory. Dr. Jim Gregory is a professor in the Department of Mechanical and Aerospace Engineering and is the director of the Ohio State Aerospace Research Center. He received his doctorate and master's degrees in aeronautics and astronautics from Purdue University in 2005 and 2002, respectively. He received his Bachelor of Aerospace Engineering from Georgia Tech in 1999, graduating with highest honors. Dr. Gregory's research interests lie in the field of unsteady wakes, with specific interests in rotorcraft aeromechanics, bluff body wake control, and the development of advanced measurement techniques. Dr. Gregory has spearheaded much of the research around unmanned traffic management systems, especially with the Smart Mobility Corridor as a PI here for Ohio State, working with Fred Judson and Drive Ohio, and is definitely leading the way here at Ohio State on our UAM efforts. So it's my pleasure to introduce Dr. Jim Gregory.
Thank you, George, and thank you for the fantastic symposium today. It is really interesting and invigorating discussion. So I'm delighted to have a conversation, hosting a conversation this morning on operational challenges. And as George mentioned, we've got a specific focus on data privacy, cybersecurity, and airspace integration when it comes to operating these vehicles, whether it's unmanned cargo or unmanned people-carrying aircraft. I'm going to start with a brief introduction to each of our panelists, and then we're going to jump right into some questions, hopefully have some nice interactive discussion. So in order here, alphabetical order, we have Ken Edge, Denis Hirsch, Sabrina Saunders Hodge, and Andrea Chefl. So starting with Ken. Ken is the Vice President of Simulation and Exploitation Operation for Radiance Technologies, located in Dayton, Ohio. So their operation focuses on modeling and simulation, cyber vulnerability assessments of non-traditional systems, cyber exploitation of complex systems, and cyber R&D to accomplish the operation's goals more efficiently and effectively. So it's a wide range of, basically he's a Uber hacker, I would say, and he knows how to get into your systems. Prior to his industry experience, he spent 20 years in the Air Force, where he was a chief of the Rapid Technology Integration System Warfare Division, Sensors Directorate of the Air Force Research Laboratory in Dayton. He was responsible for directing over $5.5 million annually in external funding for both classified and unclassified customers to rapidly develop and prototype various technologies for the warfighter in operational environments. He led 150 government employees and contractors in the production of software, hardware, and cyber-based protections for critical U.S. technology. Prior to that research role, Ken was a senior pilot in the Air Force with over 2,800 flight hours in various aircraft. He's a graduate of the United States Air Force Academy in 1993 with a degree in electrical engineering. He has an MS in electrical engineering from 1998 from Wright State University, and a PhD from the Air Force Institute of Technology in 2007. Ken, thank you for joining us. Next, we have Denis Hirsch, who's a professor of law and the director of the program on data and governance here at Ohio State University in the Moritz College of Law. He also holds the title of professor of law at Capital University Law School. Professor Hirsch's research interests lie at the intersection of governance theory and information privacy law, and he's written extensively in this area. He also writes about European data protection law, comparative information privacy law, and the instructive similarities between environmental law and privacy regulation. In 2010, he served as a Fulbright senior professor at the University of Amsterdam, where he produced a leading study on collaborative Dutch data protection regulation. He's published articles in a number of leading law journals, and he's the co-author of the book Environmental Law Practice, Problems and Exercises for Skills Development, which has been adopted by a large number of law schools, over 30 across the country. Prior to joining the Moritz Law faculty here at Ohio State, Professor Hirsch served as the Geraldine W. Howell Professor as an Associate Dean for Faculty and Student Development at Capital University Law School. He's been a visiting professor at Notre Dame Law School and at Drake University Law School. He's a reporter for the Uniform Law Commission, Drafting Committee on Employee and Student Online Privacy, and a number of other service activities where he's actively engaged in the law community. He's a graduate of Columbia and the Yale Law School, and Professor Hirsch has served as articles editor for the Yale Law Journal, as law clerk to the Honorable John M. Walker, Jr. of the U.S. Court of Appeals for the Second Circuit, as an associate as Sidney Austin, LLP, and as counsel to the firm at Porter, Wright, Morris, and Arthur, LLP. Professor Hirsch, thank you for joining us. Next, we have Sabrina Saunders Hodge, who's of the Federal Aviation Administration UAS Integration Office. Sabrina Saunders Hodge is the director of the Unmanned Aircraft Systems Research Division within the FAA's UAS Integration Office. Within this role, Ms. Saunders Hodge is responsible for coordinating internal and external to the FAA development of the FAA's UAS research plan to inform rulemaking framework for safe and efficient integration of unmanned aircraft into the National Airspace system. Prior to joining the UAS Integration Office, Ms. Saunders Hodge was the manager of the FAA's Next Gen New Entrants Division, which is basically all kinds of new things happening in the airspace system, with program management responsibility for executing UAS research, as well as standing up the FAA's first UAS Center of Excellence, of which Ohio State is a core partner. And I've had the privilege of working with Sabrina over the years in that context. Over the past 25 years, Ms. Saunders Hodge has worked in the field of satellite communications. She's contributed to the development of ICAO's global plan for transitioning to future communications, navigation, and surveillance and air traffic management systems for civil aviation. She co-managed the oversight of the FAA and European cooperative research and development initiatives. So in that context, she had a lot of international collaboration in defining standards and ways of mapping out the future of air transport, with specific focus on integration into the National Airspace system. Ms. Saunders Hodge holds a BS and MS in computer science from the University of Maryland and Johns Hopkins University, respectively. Additionally, she's a certified project management professional and a graduate of the Federal Executive Institute. Sabrina, thank you for joining us. And then Andrea Chefl. Dr. Chefl is the UTM product manager at Aeros. And Aeros is a arm of GE Aviation. Started off as a GE Ventures, and they're a partner with us on unmanned aircraft traffic management under Fred Jetson's program. Prior to joining Aeros, Andrea was Senior Director of Project Management at EXA Corporation, managing EXA's complete product portfolio, including their flagship CFD solver, PowerFlow, and other visualization, cloud, and optimization products. She joined EXA from NASA Ames Research Center, where she provided CFD analysis on the Orion launch vehicle, which is sitting here in Ohio today under testing. Andrea holds a PhD and MS from Stanford University in Aeronautics and Astronautics, and a BS in both mechanical and aeronautical engineering from University of California, Davis. She's a senior member of AIAA and a member of the SAE. She currently lives in Boston, Massachusetts, and enjoys equestrian riding, CrossFit, and spending time with her family. Andrea, thank you for joining us. So with that, with our panel here, I'm very excited about the discussion that we'll have. I would like to invite each panelist to comment on the following. Basically, an open-ended question from each of your perspective. What is the most significant operational challenge facing urban air mobility today? And in the prior panel, They discussed a definition of what UAM is. So hopefully that provides the context. It's a fairly broad definition. But let's take an operational focus. What's the most significant challenge that you see that's not receiving enough attention today? Andrea, how about we start with you?
Sure, thank you. So I will start with acknowledging that we're doing a lot of really great work today in what I would consider micro ecosystems. The Smart Corridor is a great example of that, bringing together a number of partners, industry companies, to create an unmanned ecosystem to prove out how it would work. I think the biggest challenges for operational UAM or urban air mobility would be in taking that micro ecosystem and creating or merging it into the existing ATM ecosystem. So these micro ecosystems are highly digital. You need a digital system for autonomous systems to work and communicate with one another, but the larger overall air traffic management system is not digital. There's a lot of manual communication, communication over radio, people in the loop, and getting the data integration from these micro ecosystems into that bigger ecosystem is going to be one of the really big challenges for the visual or the vision of urban air mobility becoming a reality.
Sabrina, how about you?
Thank you. From the regulatory stance, I would say more standards. So, you know, there are many standards for manned aircraft. We're certainly evolving the standards for UAS. And for the FAA, we're trying to move from prescriptive approvals and means of compliance to performance-based. So I would say there's, not that people haven't been working, but I'd say that there's an insufficiency in standards that we can reference in order to progress our performance-based process.
Thank you. Dennis?
So first of all, I'd like to say that I think none of us want to live in an environment of constant surveillance. And I'm not talking about criminals or wrongdoers that are trying to get away with things they shouldn't get away with it, but I'm thinking about regular people who do things that they don't want to share with everybody, like go to the psychiatrist or go to the cancer doctor, or want to share when their child is walking down the street, or when they're away from their house that burglars might find out. I think none of us want to live in an environment where everything we do and where we go is known. So when I look at this field, I see real threats to that, both with the unmanned and the manned air vehicles. Unmanned especially, you know, I'm not an expert in this technology, but my understanding is that current drones can be equipped with gigapixel cameras that can take video streams of 10 frames per second for 65 targets at a single time. That's a lot of information. For the manned vehicles, and you know, when we are being transported around cities, there's our location data, much like with autonomous vehicles, that's being revealed. But here, possibly, air traffic control has to happen from the government, so you have to have government knowledge of where all these vehicles are going. So that's direct government knowledge of our whereabouts. There's no Fourth Amendment protection there. So that's potentially an issue. So I think there's real significant privacy concerns here. And the thing that doesn't seem to be getting enough attention from where I sit is regulation to address that. I've looked at the FAA's statutes and you know, beginnings of regulation on the privacy issues in this area. There are things like requiring companies that operate these vehicles to provide notice of their of where their vehicles are, or of their privacy practices. And that's kind of traditional privacy regulation, but that doesn't fit this scenario, right? I can't know what company's drone is above me. I can't know what website to go to check the privacy policy. And even if I don't agree, what can I do about it? The FAA's authorized to require operators to respect traditional privacy protections as established in federal and state law. What does that mean? I mean, I'm a lawyer, that's very, very broad, and, you know, whose vision of privacy? So I think right now the regulatory approach to this is very underdeveloped. And as George said in his initial comments, I think it's really important to be proactive about this area. I'm excited about this industry. I think these technologies are cool. I think there's a lot of really exciting, interesting things that will happen. But if the privacy issues are not proactively dealt with, there will be significant public pushback. So to make this industry successful and to make this industry sustainable, it's important that energy and thought be put into developing a regulatory framework so that the technology is developed in accordance with our values rather than our values having to just accommodate to the technology.
Thank you. Ken?
I'm going to piggyback a little bit on what Dennis said. I believe the biggest operational challenge is a regulatory system, but it's a regulatory system that works. It's easier said than done. It's a very hard problem because the first question is who's in charge, right? Is it the FAA? Is it DOT? Is it DHS? All the above, even FCC when you're transmitting. Is it federal? Is it state? Is it local? Yes, it's all the above. So there's a lot of coordination between a lot of different government organizations that has to happen, and that's very hard, right? So that's the first challenge. The second thing is it has to be a regulatory system that really helps the public see that there's security and safety in these systems, right? Because that security and safety and public trust is going to drive consumer demand. If we see an early crash of one of these that causes a lot of loss of life, that's going to set everything back, you know, a decade, because the public is going to go to their elected officials are going to get involved, and they're going to just, you know, squash everything. So that safety and security in a regulatory system, that's, again, it's important, but it's hard, because how do I define that? You know, I come from the cybersecurity world, and I can tell you, you know, make your systems cyber secure, but can I tell you what that looks like? You know, I can tell you how to break it, but it's hard to tell you how to design a system sometimes that is secure. The other thing is making it a clear process, right? So there's a lot of innovative companies, small companies in this space, and you know, if you're a small business owner or a large business owner, you understand how much regulation there is. How do you navigate it? Who do I talk to? I mean, what forms do I need to fill out? Making that process clear, because if it's not, people will either run afoul of it, or it'll be so onerous that they'll just give up, and you'll really knock the little guys out that are going to be the innovative people in that space. And the third part, which goes along with that, is cost. You can't make a regulatory process so expensive that it drives the cost of these systems up, that they're not, you know, for the average user. Because, you know, helicopters, yeah, a lot of rich people, as we were talking this morning, fly helicopters to and from work already. But most people can't afford the millions of dollars they cost. And a lot of that is not just the technology, but it's the regulation that goes with it. So we have to make sure that this process is robust enough, but also cost efficient, so that it doesn't affect the cost too much.
Great, thank you. So I would like to pull on a thread a little bit and hear some of your comments specifically on maybe coming back to Andrea's thought of the digital ecosystem. And if we could talk about what kind of thinking should we be doing now in terms of the design of that relative to what kind of data do we need to ensure safety of the operation of these vehicles? How do we need to protect that data, both from a privacy and a cyber aspect? What do we need for certification? If you all could just comment on the digital ecosystem that will be needed to enable this.
All right, I can start. So I think we can think of what the digital ecosystem will look like eventually when we get there. We can look at the end state, but I think it's actually more valuable to look at the baby steps that we can take to get there. One of the really key aspects, I think, in getting there is the start of sharing UAS traffic management data with the manned aviation world. So there's been a lot of pushback from air traffic controllers and airports saying, well, look, we got our hands full. We're already looking at too much data. Our air traffic controllers are way too busy already. We can't pull their eyes off of that screen. And that's true, but that doesn't mean that we still can't share operational data with their managers or with other people involved in the aviation industry. And the beginnings of that sharing data will help us to build or to think about what the ecosystem should look like and how it should operate and how the roles of the traffic managers will evolve as things become more digital.
Actually, I want to comment on that. I think, as Andrea said, there's going to be a lot of data that goes between manned systems, unmanned systems. So I think automation in this ecosystem is key, and I don't mean it from the point of a single vehicle is automated, but how do you make decisions between vehicles with traffic, who has priority? With that, though, I'll bring my security hat in, is who is making those decisions and are they secure? There's going to be a lot of artificial intelligence, machine learning that goes along with this, and what is the training data that is used? Again, this morning we talked about there was somebody in Germany who had a wagon full of hundreds of phones, and they dragged it around a neighborhood, and your Waze or Google Maps showed that there was a traffic jam there and would route it around. So if somebody can do that, I mean, that he's just a regular user using the system as it's designed, but he spoofed it, if you will. What if somebody does that in our urban air mobility construct and tricks the data, if you will? So this ecosystem that is making decisions, there's so much data, it's going to have some level of automation, but we have to make sure the security is part of that as well.
And building, go ahead.
I just want to pick up on something that was said earlier about trust and the importance of trust. So an ecosystem is an interesting analogy. And ecosystems, require resources in order to function, right? And if they don't get the resources they need, they can collapse. And I would argue that an essential component of any digital ecosystem that's going to support this type of technology is digital trust. Without it, if people lose trust because a vehicle, crashes and people are killed, so from a safety perspective, or frankly from a privacy perspective, if people have a sense that their data is maybe going to be used against them in some way, people will pull back and they will pull their data back from this ecosystem. And the ecosystem will not be able to function. So I think a set of kind of rules of the road, a set of parameters that proactively sustain the needed trust resource that is an essential resource for this digital ecosystem is a very important aspect of it.
So within, to piggyback off of everyone up here, so within the FAA, and I know, everyone has said, the regulator and regulations are certainly a hard nut to crack, and that's because, for a regulator and FAA for sure, safety is first, and we want to enable all of, the technology, and we are, we are partnered with industry and our, NASA partners, conducting UTM pilot programs. We're in the second phase of that, trying to look at the ecosystem and this digital, the transfer of data and the security of data and communications between vehicles and separation assurance, and now moving into UAM, which industry and government has worked on, UAM for decades, but now it's, has a lot of cachet now. And so we are certainly partnered with NASA on their grand challenge. So we really value the learning from research and operations in order to inform the regulatory system moving forward. So that's why we depend on industry, we depend heavily on academia to really be out in front of us and do those exploratory missions, demos, so that we can learn and so that we know how the regulatory system has to adapt to the possible that you all end up exploring and proving. So, thank you.
Great. And building on that, a question that's on my mind is when we think about a digital ecosystem and then contrast that with our current, I would say, very analog approach to managing air traffic. Both Ken and I are pilots, and the current paradigm is if we want to do anything in controlled airspace, we're getting on a radio with voice communications and communicating with air traffic control. But now we envision this new paradigm with air traffic management that Andrea and I are working on with others. It's a very digital space. How do we get from the current paradigm to the future? Sabrina, do you have thoughts on that, since you all are the air traffic controllers of the world, or of the United States?
Certainly, and I don't know that there will ever be just a total movement. I mean, it's going to be a slow progression. We always have to have redundancy in the system. We have to rely on, what we know works. We have to maintain the current level of safety while we introduce, new vehicles, new entrants. We have now the commercial space vehicles, not just the UAS and the UAM. So I would say we're working on that, and certainly it's going to take a partnership with industry. As we've seen in the even our Lance system and UTM, because we can't do it alone. We need industry to help us with the collection of data, the transmission of data, and then we will use it for our purposes. I mean, we at those lower altitudes. I mean, FAA does not provide surveillance and communication, services, and nor do I think we can't. It's out of affordability for us to do that. So we heavily rely on industry to really provide that ecosystem for the lower altitudes. The analog, well, we will have our air traffic controllers, at the higher altitude. So I don't know how, that might change.
So the current thought is kind of a segregation of airspace?
Well, we don't like to use that word. No. We are, trying to move towards integration. And so, no, segregation certainly is not in our vocabulary. We are working to figure out how everyone can commingle and, the rules of the road. But, no, we are not trying to segregate.
One thing I think that compounds this problem is in manned aircraft, obviously the operator is co-located with the vehicle and is talking to maybe an air traffic tower that is right in the vicinity. In this space, you could literally be thousands away, and I don't want to call it even an operator because it might be a monitor, somebody that's controlling those vehicles. And so how do you build that ecosystem that pulls all that together in this massive single digital ecosystem? Now there's security things, because again, if I have one ecosystem and it goes down, the whole network comes down. So I think that's another issue is the co-location of the operators with the vehicles themselves.
Yeah, I would say, coming off of what Sabrina was talking about, this ecosystem that we're building is, we're moving toward this massive brain, right? And if you think about how a brain evolves, you build one neural pathway at a time. So if we work on just the transmission of data between stakeholders one at a time, if you could take the example of a traffic incident, let's say a state police has a drone program and they want to use a drone to survey a traffic incident. But at the same time, it's a severe enough incident that they also have a medevac helicopter coming in and they're going to have media helicopters coming in. That's a really great example of an opportunity to share data between unmanned and manned vehicles. So how can we do that? It's not going to be through the FAA. The Lance program, for example, is one of the neural pathways that we've already connected. But how do we create these other neural pathways where we start sharing data today to make a difference in the lives of people? And, that will go, again, toward the acceptance of drone operations, drones for good, doing good things. But we can do this today. It's not rocket science.
Great. Another question I have for you to consider, an open-ended question for each of you, perhaps. What do you think are the most significant misconceptions that the general public has about the urban air mobility space today? And again, broadly defined. What are, from your perspective, the misconceptions?
I would say along the regulatory theme again, I'm going to keep hitting this, but that the regulation is out ahead of the technology. I think the public might believe that, and it's not, right? The technology is really already here, and we're catching up with regulation, trying to figure out how do we kind of put this, cat back in the bag there. But we're trying to figure it out as we say, flying the airplane as we're building it. We're doing that in a sense.
I don't have a kind of empirically based sense of the misconceptions, but a general sense. I do think people sometimes get more alarmed about privacy issues than they need to be. And so, and that can happen in this space and may be happening in this space as it has in others. So, accurate information and transparency is, in terms of data collection and data use, is really important to having people react accurately to what's happening.
So there have been, many public studies on perception of UAM. I would say, as we heard earlier, they're driving cars, they're for-hire helicopters, similar to for-hire helicopters, and or scaled-up UAS, and I would say all three of those are somewhat misperceptions. We look at this whole UAM dynamic, certainly as an ecosystem, it's been said over and over, with the components of airspace, the aircraft, the infrastructure, which we've talked about, operations, and then community acceptance and trust. So those are together very complex, and that's FA is challenged to look at those areas and how they interrelate. So I guess that misperception is just, it's just another technology. No, it's an entire ecosystem that has to now be integrated into the current national airspace, and that's not trivial.
I would agree with that, Sabrina, entirely. I think one of the other misconceptions is that urban air mobility is this new kind of standalone thing, and it's not really going to have that much of an impact on traditional air carriers. But that's not really the case. If you look at the automotive industry and autonomous vehicles the technology that they're using to automate cars is impacting the entire industry. And you can take the same look at the aviation industry. If we create autonomous air taxis, why wouldn't we start taking pilots out of aircraft to make air travel more affordable, or pilots out of air package aircraft? These are things that we can apply this technology across the entire industry, and we should be looking to do that. It shouldn't just be this one niche of getting people into a Jetsons style taxi.
Yeah, and to follow up on that, so let's take the Jetsons Vision of a fully autonomous, meaning no pilot on board. What do you think is the likely end state, and will there be some intermediate steps? What will it take to, will we have a pilot on board or not? And under what kind of time frame will that be? Because I think different people have different visions on this, because it has an implication on how you design the vehicle from the outset. If you're not going to have a pilot on board, you can save a lot of weight and cost. So there's huge benefits to doing so, but also great technical challenges. So what do you think the outlook is? Will there be a pilot on board in the near future, the long term, and what are the challenges?
So I'd say initially there will be a pilot on board if there's going to be passengers. I don't think there needs to be. I think we could skip that step, but I think because of public trust and security and safety, that there's just going to be a pilot on board. I mean, if you look at airliners now, there's two pilots on board, right? Does it really need to be? They're basically there to handle emergencies. The airplanes can already take off, fly, and land on autopilot, today. But there's two pilots on board, and that's mostly for the passengers' comfort in the back. So I think we could skip that step, but I don't think we will. Unfortunately, that will drive design decisions, as you said. So we could have much more efficient systems. They could go longer distance, carry more people. But it's much like Uber and Lyft. We have autonomous vehicles. The technology is almost there, but they are really using people to drive those, to build their platform while they're developing the technology in the background. And then, eventually they'll replace those drivers and those will be autonomous vehicles. So I think that'll be the same model that happens in UAM.
Yeah, I would echo the same thing that, there are a lot of parallels that we can draw from the autonomous vehicle industry. Their paradigm is first you have your feet off, that would be cruise control. Then you have your hands off, which a lot of cars already do, which is lane departure. Then you have your eyes off, which is a combination of those two maybe. And then brain off and body off, which is where you're sitting in the back seat and the car's driving itself. And we can take the same journey with aircraft, and as as Ken mentioned, aircraft already have autopilot, so a lot of that technology is already there. It's just a matter of walking the public through these steps so they feel comfortable that yes, this plane can fly itself. Yes, the pilot can take their eyes off the controls, they can take their hands and feet off the controls, they can take their mind off the controls, and eventually their body off, and then we can get to that end state.
Thinking about the pilots, the perhaps excess, in pilots to preserve trust, and then trying to think about the privacy perspective, protecting the data, protecting people's privacy, is that like an extra pilot? Is it just added weight that's not really needed, except that we want to preserve people's trust? And I guess I would invite people in this industry to think about how trust protecting, privacy protecting versions of this technology actually make you more competitive rather than less. It's not just added weight, but it's a preference of your consumers. And so it's better quality to do this technology in a way that is more consistent with the world people want to live in, and with people's well-being. So I'm just kind of reacting, because I'm thinking about trust, but I would encourage people to think about the privacy and kind of ethical dimension of this in a different way than just we got to do this because people expect it.
Well, certainly, again, back to the FAA and the regulatory system, if it's an aircraft, there is going to be a pilot, for a long time in command. And so I expect that as industry and technology, progresses, the requirement for a pilot might wane. But going back to what I said earlier about standards, I think we need to look at standards that really home in on what are the things that a pilot does today in a contingency situation. Yes, we have the autopilot, but there's more to having a pilot other than just the passenger comfort in the back. We've seen that with Miracle on the Hudson. Sometimes a human just has to intervene with the years of experience and just being able to react. So for that, again, standards and just really nailing down, what does the pilot bring, to a flight other than just, being able to control the instruments. So yes, I think you will see pilots required for quite a while.
Great, and perhaps my final question, since we're near the end of our session, touching on this idea of a pilot and autonomy, let's think about the 737 MAX. I think everybody in the room is familiar with, about a year ago, the two high-profile accidents that happened. And there are a lot of different ways of looking at that, but one dimension of that was the autonomy and the pilot. And the vehicle doing things that the pilots didn't understand. Can you comment about the challenges associated with having a pilot on board with some level of autonomy, and what happens when the autonomy is saying, no, this is the right thing to do, and then the pilot is doing something else? Comment on those challenges as you see them.
Yeah, being trained as a pilot, pilots are trained to do exactly what they're trained to do in an emergency situation, right? They really, I don't want to say they stop thinking, but they revert to their basic training. And so when something conflicts with that is where we typically see accidents, right? The system's telling me this, but I think this. And again, as a pilot, you're trained to not go with your gut, to trust your instruments. And so in autonomy, when from the security aspect, somebody tells the instruments they're doing something else that's not really accurate, I'm afraid the pilot would follow those instruments because that's what they're trained to do with spatial disorientation and other types of human factors aspects. So from a cybersecurity guy like me, a lot of people will say, well, their pilot is your backup, and maybe I couldn't jump what we call the air gap before, but if I can get the instruments to say something, I can get the pilot actually to do what I want him to do in that situation. So it can be a problem. I mean, and in the autonomous vehicle space, I truly believe that autonomous vehicles will have much fewer accidents than manned cars. But every time there is an accident, it's a very high-profile, newsworthy event. And so I think the same thing's going to happen here. Autonomous airplanes, if you will, or UAMs, probably will have fewer accidents once the technology is proven out. But as people, we don't typically trust that. And so when something happens, we say it must be the system. And so you're going to see a conflict here between the pilots and the autonomous systems.
Yeah, I would agree with that sentiment. I think, going back to, again, the autonomous vehicles, right, the end stage is body off. And a lot of people think that means no pilot at all. But for aircraft that are carrying people, that could actually mean that the pilot's just not in the plane, that you have an autonomous system, but you have a pilot somewhere else on the ground that doesn't need, and that may change the human factors of the situation as well. So I think there are a lot of things to think about when we get to this end stage. Is there still a human in the loop? Is it a pilot? Is it an air traffic controller who can double as a pilot if there's a contingency plan that needs to be enacted? There are a lot of possibilities here that we're just now starting to think of that I think makes it a really interesting problem.
And just to piggyback on what you said, we've already approved for UAS, multi-operation. So while I said, a pilot in command, we have now, approved for, as long as there is, you're saying a pilot in the loop, a manager that can react if there is a contingency situation or there's a need, an emergency situation that is called, by the FAA. So there are just going to be varying degrees of, where the pilot is, on the ground in there. But I think we'll always look for at least having that manager to be there when there is an emergency or a contingency.
Okay. Thank you. Well, I think that's all the time we have. And thank you, everyone, for a very interesting discussion, and appreciate your time today.